Alright, because Module 3 is about bending and the bending stresses, and it turns out to be a very simple equation, but yet the background of it is complex, and actually overall bending is fairly complex as a model. What we're going to do here real quick is just a logistical overview of how this mini module is going to get broken up. That's right, a mini module, because we're going to actually break up stresses associated with bending into 3 different modules, and just because it's that complex, right? So in this mini module we're going to have 3 basic lessons on the normal stress that results on the cross section due to bending, and then we'll have 3 lessons on the transverse shear stress on the cross section due to bending, and then we'll have a whole bunch of lessons associated with the deflection related to bending. Here, just only normal stresses and those 3 lessons. Now, this first lesson is going to get broken into a whole bunch of pieces, right? And really, the formula that we're going to end up with is very easy to apply, but boy, there's a whole lot of pieces in the background of applying it correctly. So easy to apply, but only if you know what's going on. Right, so prerequisite to understanding all this stuff, note here we got a whole laundry list of things, some of which are from just basic math skills, such as the arc length formula, and then a whole bunch of stuff associated here with this course content, Hooke's law, definition of normal strain. We need calculus and the definition of curvature and radius of curvature, and then depending on your view of the last 2 centroids of areas and second moments of area, either that's calculus or it is statics. Just all depends on how you would like to classify that. Right? All that bullet point stuff is then listed down here. The critical equations, you got that all compiled together. There's the arc length formula and some other things that are going on. We'll come back to these things in detail. Ooh, look at all these beautiful calculus-like equations. We'll come back to that too. So there's a whole just subset, 3 pages really of just that math stuff, and then because it's all going to we're bringing together all these different concepts all at once, there's some home study problems here. The first one is just purely about remembering how to find a centroid of a cross section, finding the second moment of area, and then there's an extension to an application here. So this guided home study problem is a both before and after the lesson kind of thing. This one is all well, not all. This one's the same kind of thing. This one, find the centroid, find the second moment area, then apply the model we're about to develop. This one is entirely just a review of finding second moments of area, giving you different cross shapes, giving you answers that you can practice on. Right? All of that is sort of both prelude and postlude, or postlude, to deriving the Bernoulli-Euler beam model. Right? And so this is the heart of what this lesson really is about, applying all that stuff. That takes 2 pages. We're stacking up a lot of pages. And then finally, we have one series of, well, it's one example doing the same thing to 2 different cross-sections. And that is everything that is included in this first lesson on elastic bending stresses. Right? So it'll take a long time to get to the punchline, and you really need it all in order to understand how to adequately apply the basic model that we're going to end up with.